Channel, and this is the editorial for task N slimes on the AtCoder DP contest. So essentially you have N slimes and they each have a size AI. You need to combine all of them into a large slime, right? All into one slime. And you can only combine adjacent slimes, and the cost is like the sum of the sizes of the smaller slimes, right? Like before you combine them, or that's also just the size of the slime after combining. And N is less than 400 and AI is less than 10 to the 9. So let's look at this here. There's 4 slimes here. The size are 10, 20, 30, 40. So let's see if we can figure it out by hand first. So if we combine these two like that, that's 30. This one here is 70, and though that's the two costs, now we have to combine these again. So then the total size is 100. So if we sum these up, then the cost is 200. Okay, can we do better? What I do notice is in the calculation, 40, which is our largest number, is being added twice, right? It's included in the thing for 70, and also, of course, that's part of the thing for 10. So one way of doing this less is to try to have the smaller numbers be added more. So if we do this, so that's cost of 30, then we combine these two, that cost is 60, and then we combine these, now we get the full slime of size 100. Now the cost for this is 190, which is in fact our optimal solution. Okay, so how can we do this using DP or using smaller subproblems, right? So if we do this one step at a time, right, we look at the full array, right? How can we break this down into smaller problems, right? So for this, they have to be adjacent. That's one thing, right? So if we're talking about this full slime and try to find out the previous step, there's 3 different options, right, to cut it up. It's either 10 and all of these, or these 2 and these 2, or the 10, 20, and 30 and 40, right? And if we already know what the cost is for each of these subarrays to combine them, then all we need to do is we sum up the cost of each of these, we find the min of that, and then we simply add the total size of the slime, which in this case is 100. And this will of course solve our problem. So let's see if we can make this work within the right time complexity. So to do something like this, let's have the DP first. You would have a DP, it would be I and J, and these are just the left and right bounds of the current subarray, right? So this will say the min cost for this subarray, okay? L to R. So how would we calculate this, right? You would loop through by size, right? Because the subproblems for a bigger slime are just, smaller subarrays, right? So you'd have size, and it would be from 1 to N. And of course, if it's DPI to I, that's obviously 0, right? Because we haven't combined anything yet. And we do for I, which is 0 to N minus S, and then J would equal to I plus S. This would be minus 1. Let's say it's like inclusive, right? And then from here, we would want to find all of the different ways to split it, right? Which would be basically from I to J. And then we would basically do dpi j equals min of dpij, right? We're trying to find the min, and dpi I to k, the cost of that subarray, plus the cost of k plus 1 to j, which is the remaining after that, right? Plus, ai plus 1 all the way to a of j, right? Because that's like this here is the total cost, or it's the cost of the last operation, right? Which always has to be there. So let's look at the complexity here. So this is n, the size is n, this loop is I to j, which is essentially n, right? Amortize, whatever. And here, to finish this calculation, is also n. So the complexity of this solution is O of n cubed. And since n is 400, this won't fit within our time solution. But there's a simple thing we can do to eliminate one of those factors of n. We can just use prefix sums here, right, to replace this final calculation, and that makes this calculation O of 1, which makes our final solution O of n cubed, which fits fine within the solution. So I hope this helped. Thank you for watching, and I'll see you in the next video. Bye.